Hi, welcome back to Manohar Academy. In this lesson, we are going to learn about Java inheritance and typecasting. Here we have three classes, person and employee. Employee extends person, and manager will extend employee. Because of this, we have a inheritance hierarchy. That is, manager is subclass of employee, employee is subclass of person, and person is subclass of object. We have already seen that when we are creating objects, a superclass reference variable or reference variable of type superclass can refer to the object of subclass. So here person is superclass and employee is subclass, and superclass reference type variable is referring to subclass object. So this is perfectly allowed. If we think it in terms of primitive variables, we have previously seen that in case of integers, just to represent integer values, we have four types: byte, short, int and long. In this case they are different because the values that they can hold are different. Byte can hold very short range, very little, few values. Short can hold few more values, and integer is a bigger than short and long is bigger than integer. So we already know that we can assign byte to short, short to int, and int to long. So similarly, we can assign person to person, employee to person, manager to person. So you can make a comparison there. Also, if you remember, if we try to assign a short variable to byte, we can't do that because short may be holding a greater value which cannot be fit into byte. But as a programmer, as a developer, if you know that in this particular variable there is never going to be a value bigger than byte, you can safely typecast it, and compiler will say, if you know that there is going to be byte in the variable of type short, I'm okay. And what happens at the runtime? If there is a value bigger than byte can hold, then the truncation will happen and you never get any runtime errors. So with the primitive types, you can typecast explicitly whenever required, and the problem is that during runtime, if at all the variable is holding a bigger value, you are going to get a truncation, but you are never going to get a error. You are only going to get some wrong results because of the truncation. Okay, now if we apply the same logic to the inheritance hierarchy, remember here the size is not the problem. Here the problem is the functionality. Person has only small functionality. For example, you can call only method 1 on person, but coming to employee, he has more functionality. On employee, we can call method 1 and method 2. In manager has some more functionality. We can call method 1, method 2 and method 3. So here also, because of that reason, if you are trying to assign a person to employee, you are going to get a compilation error. Basically, you are assigning a object of less functionality, right? Because this is being referred by person, here it is considered as a person. Person has less functionality compared to employee, so you can't assign that, because now if I call employee dot method 2, this object, whatever object is there, it doesn't have a something called method 2. So because of that reason, the compiler is not going to allow assigning superclass type to subclass type. But if you know that inside the person variable there is going to be only employee object, then you can explicitly typecast. So this is allowed. So in case of primitive variable, you know that the value is short, value can be accommodated in the target type, so you are making a typecast. Here you know that the variable is pointing to proper object, then you can typecast. But here in reality, the person variable but I don't write the name here, but I am writing only variable of type person. So if you see here, the person is of type person, right? Is referring to a object of type person. So let me keep that in the double quotes. So the variable is of type person, and also the object it is referring to is of type person. But we are assuming that this variable is pointing to an employee, and we are assigning, we are typecasting it to assign it to employee type. So even though compiler is allowing by taking us at the face value, like compiler is believing that the variable is referring to a object of type employee, that is the reason it is allowing us to typecast. But at the runtime, if I execute this one, I am going to get a typecast class cast exception, because if you see the error message, it says person cannot be casted to employee, because every person is not employee. Some persons may be students, some persons may be anything. So every person is not employee. So because of that, it won't allow you to typecast a person to employee. Okay, so by doing the explicit typecasting, we were able to avoid compile time error or compilation error, but at the runtime we are going to pay the price as a exception. So we are going to get the exception, and the program is going to terminate. So for example, now here to the person object, person type, I am going to assign employee object. So this is perfectly allowed because employee is a person, so you can assign employee to person. Now if I have to write this one, what is that? The variable of type person, because the person is still of type person, is referring to object of type employee. Now if I do the same typecast, it won't result in first of all, if I don't have this particular casting, the compiler is going to give us error, because person is of type person, employee is of type employee. So we have to write the explicit typecast. If we run now, but before running, I'm going to comment line number 48, because that is going to give us a runtime error. I commented out. So we have only 2 lines of code, and variable of type person is referring to object of type employee. So now it will run successfully. Actually it ran successfully, and so it ran successfully and there is no output message. Let me print something. So here you can see that it ran successfully. So if the variable is pointing to the right object type, then the typecast will succeed at the runtime also. Okay, now can we check to which kind of object the variable is referring to? Yes, we can do that. So here I am going to write if person is instance of employee, then do this typecasting. Okay, so here we know that, but now here I'm going to keep it here, then I'm going to execute this one. So obviously if I don't have this statement, if condition, then this statement is going to get executed. But because now I have this particular statement, particular if condition, the statement won't get executed. Let me run it. So if you can see here, there is no runtime error. So because before typecasting, we are checking whether it is an instance of employee or not. The object the person variable is referring to is instance of employee or not. So whenever you have to do the explicit typecasting, please make sure you do a check using instance of in order to in order to have successful typecasting at the runtime also. Okay, one more thing about instance of. Now can I check if employee variable is instance of manager? I can do that. Sorry, I can do that. Compiler is allowing me to check whether the object held by this variable is of type manager or not. But if I write something completely unrelated, it knows that employee can never be string, so it won't allow that. You can't write anything other than something in the hierarchy line or this particular one. So you can write only these 4 types after instance of. If you write anything else, it is going to give you a compilation error. Okay, that is all about this lesson. Last but not least, if you haven't subscribed already, please go ahead and subscribe. If you are benefited from this video, please make sure you like it and share it with your friends so that they can also watch, they can also learn. Thank you once again. See you in the next lesson.